Hello students, today in this video we are going to discuss about random errors. So in the previous video we discussed about systematic errors and different examples of systematic errors just like zero error and parallax error. So if you have not watched that video, you can revisit and see what is systematic error all about. Now today in this video we are going to discuss about random error. So I will just tell you about random error and we will take few examples. Okay, random error. So what do you mean by random error? As the name suggests, the error is random. What do you mean by this? If an observer is taking any reading, is taking any measurement, okay, an observer is taking n number of readings, then these n number of readings will have different amount of error in each of the readings. Okay, so then we will say it is random error, right? Then what is the root cause of random error? Why you are getting actually random error? Okay, so random error can be because of many parameters. Like, when you are measuring any event, what we said, we will have to consider the variables, right? What are the variables? One is the independent variables that you are changing, right? And the dependent variable that you are measuring using an equipment, dependent variable. And then there are control variables, right? So here you can see these control variables means you need to control these variables. Okay, control variables, okay, you need to keep them constant. Then you change the independent variable and measure the dependent variable in any experiment or in any study, right? So in some cases these control variables actually not constant and you won't be able to actually control these variables. For example, if you are doing any experiment related to thermal physics or thermodynamics, okay, suppose I will say thermal physics. So suppose you need, particularly in this experiment, the temperature, the surrounding temperature, okay, is constant, temperature is constant, but you are doing it in a lab where the temperature is not controlled, right? Is not controlled, is varying, right? Then you will say actually this is not kept constant. The environmental conditions, okay, environmental condition, when I said environmental condition, what are the environmental condition? The laboratory condition, particularly I'm saying, if you are doing it in a lab, okay, controlled lab. So environmental conditions such as, you can see the pressure, okay, conditions such as pressure, the humidity, okay, or some parameters like this, humidity inside the room, right? Like temperature also we considered, right? Whether there is wind inside, some experiment will also be affected by wind speed and all. So there are, these are the variables, okay, these are the parameters which may not be kept constant. Okay, so because of, during the whole duration of taking the reading, like you took, like suppose 10 minutes, 20 minutes to take your observations, right? So the first reading, second reading, third reading, these environmental conditions may differ, like, may be affected by some air resistance, some other parameters, like, suppose you are measuring time, right? So using a stopwatch, right? If you are measuring time using a stopwatch, maybe the reaction time, right? Your reaction time when you stop and start, how much time you take to react, right, to the event, like to stop or to start. So that may not be equal every time, it may vary, right? So that will also lead to some kind of error, right? So these are the sources of random error. Okay, or you can see, like, um, there are many variables actually which cannot be, kept constant in a particular study. Okay, and because of that, the error which is developed, which is came in your reading, that is known as your random error. I'm just sharing a slide with you for more clarity. So uh, let me just share one slide with you. So here you can see what is written. Random errors refers to the spread in the values of a physical quantity from one measurement of the quantity to the next. Okay, So you are taking suppose 10 readings, and each reading is like different, like they are spreaded with different values. Then you can say this caused by random fluctuations in the measured value. So fluctuation, why are you getting fluctuations in the measured value? Because there are many other parameters which is actually affecting it directly or indirectly, like environmental factors, we said wind speed, the reaction time of the observer, or the environmental condition or lab condition. All these things may cause random error. Okay, here for example, in repeating measurements of the time taken for a ball to fall through a given height, the varying initial conditions, okay, initial conditions, can you see varying initial conditions, random fluctuations in air motion. Okay, so you can consider this the variation of your reaction time, as we just said, right, in starting and stopping the watch, that is your reaction time, will lead to a significant spread in the times obtained, right? So if your dependent variable here is time, you are measuring time, right? Then this measure time will depend upon definitely like motion of the air or your reaction time and all, right? So these parameters which actually may change from reading to reading will be inherited, will come into your reading as random errors. Okay, so now what more about random errors, if you will see, then random errors here are easily analyzed. Random errors are easily analyzed by statistical analysis. So we can take any statistical analysis depending upon your sample size and type of study. There are many statistical analysis available where you can use. Okay, so to to just analyze the random errors, right? So now what we said, these random errors actually, as the name suggested, they are random. They are not actually repetitive. So unlike um, unlike your systematic error, so systematic error, we said they are repetitive because the same value will be repeated every time, because it depends upon the incalibrated or not calibrated equipment that you consider, or you said with a zero error, or you said a particular style of taking reading by the observer, like in parallax. So you said repetitive. So in repetitive, what we said in systematic error, systematic error was repetitive. Suppose I did it in the other video, you can just refer to that. Suppose your data points are like this, right? Actual data points, the desired data points, okay, between y and x, and they follow a linear relationship between this. But in systematic error, you said all these data points will be shifted by the same amount because it is repetitive, right? So you can see with a positive y here, as you can see, y intercept can be observed. So you can, from the graph, you can notice that there is a systematic error here. Okay, so systematic error is repetitive in nature, but random error, when we said, it is not actually repetitive, it cannot be reproduced. Okay, they are different from each other. Every time the parameters that is involved may change, so they will have they will have different values, like some a best fit or a best approach can be done. But when you see, like, there is no such elevation of data points in a particular order, that means it is having random errors, and these random errors can be analyzed statistically. Okay, so this is what we said. Now I will just show you a comparison between, like, what is systematic error and what is random error. Here you can see systematic error. We said we will see more about accuracy and precision in some other video I will show you, but let me just tell you. Here you got in systematic error, suppose this is actually this red dot here, this is your actual value or the desired value, but your observed values are far away from this. Okay, and they are like all gathered over here, though they are, you can see they, the differences. Okay, the differences between all these readings are very small. They're all concentrated, they're very close to each other, but they're not giving you the actual value. They are very, you can see they are far away from the actual value. So if this happens, there is a shifting of the value, like I told you, if you are plotting a graph and you should get a linear relationship, for example, you took this x and y, you should get this, but you are not getting this, you are getting this. Okay, so this actually demonstrates what? Poor accuracy. Accuracy means you should get some value which is very close to the desired value, right? Your observed value must be very close to the desired value or the actual value, but here you are getting something else, right? You are not getting a close value to this. Suppose you took the average and your average gives you this value here, so you got a discrepancy, you got a difference between the, between your observed value and the actual value. So that means it is not accurate, but it is precise. Your readings are precise. Why your readings are precise? Because individual readings, if you will see, they are not very different from each other. So why this happened? This happened because of this systematic error. Okay, inclusion of this systematic error. But what is random error? You can see in random error, all these, observed values you see, these observed values, they are all scattered, right? And this happened because of the change in some control parameters, okay, which is not actually controlled, which is not actually the same. But when you take the average over here, average you got somewhere, very close to the desired value. And what is the actual value? I showed you. Actual value is suppose somewhere here, and you got the, you got your average value here, this black cross. I put the average of all your readings, and the red one is actually the value. So you can see the difference here between these 2 points, these two data points is very, very less. Okay, that means you are getting an accurate value. So the accuracy level is high enough here, but the data is not precise. So the precision level is very less here. So precision is less, but it is accurate. Okay, accuracy level is high, but precision level is, sorry, precision level is less here. Okay, so this is what is the difference between random error and systematic error. So when you plot this graph, actually all your data points, you can see they are scattered and not actually referring a particular, like a straight line here, or a particular linear I mean, a particular trend. Okay, so here you can just see and see your variables. Okay, they are differing from each other and all. The average value, when you take the average of all these readings, they give you a very close value to the accurate value. Then you said the data is accurate but not precision. Here you can see the precision is more. Okay, the precision here is more. Okay, but the accuracy level is less. So accuracy level is less. So seeing the data, you can check, you can say whether the data recorded for any physical quantity in an investigation, in a study, is actually having systematic error or random error, or it is having, it has high precision, low accuracy, or high accuracy, low precision. But what we need in any of the experiment or any of the investigation in physics, we need both. Okay, that means you need precision and accuracy. So what I will write, I will do the ideal one as something like this. Okay, suppose this is my value and this is my desired or actual value, then my data point should have both, like both high value of precision and high value of accuracy. That means they should not vary from each other so much, and all my data points should be very close to each other, so that when I will take the average, my average will almost coincide, this big one. Okay, my average will also should also coincide with the desired value. This is what is needed, and this will happen only if, only if there is very less chance of random error. Okay, and very less chance of systematic error. So if in an ideal condition, if you want to get the best out of an experiment, then what you need to do is, first you need to calibrate the instruments that those are used. Okay, with, and also you can pick those instruments which are sensitive enough, so that the uncertainty level or the error levels are very less. And the second thing is, try to do or perform the experiment in a controlled way, so that your controlled parameter can, I mean, can be kept constant, or may, I mean, should not actually change to a very high degree, so that you can get an ideal condition, just like shown over here. Okay, so I hope you understood what is the difference between systematic error and random error. Well, I can tell you one more example, for a simple example. Suppose you are doing a very simple experiment named known as a simple pendulum, right? Simple pendulum. Suppose you are doing. So in a simple pendulum, what you did, you took, you change the length, so you change the length. Suppose L is your, the length is actually your what independent variable, and then you measure the time period. So time period is from the mean position again to one extreme, and then this is your time period. So you measure the time period. I'm not going in detail, but I'm just telling you what is actually random error. Okay, how you can include random error over here. So you measured L and you took a particular value of L, that is your independent variable, and then you measured T, that is your dependent variable. Then you used a formula as T equals to 2 pi root over L by G. Okay, so in this formula, when you derive this particular formula T equals to 2 pi root over L by G, in the theory itself, there are many assumptions. One is what? One most important mathematical assumption, that is, this is for very small angle of oscillation. Small angle of oscillation, this angle of oscillation here, up to what extreme you are taking and then releasing the thread or the pendulum bob. So small angle of approximation, theta is very small here. Okay, theta is less than 10 degree will give you accurate value, because there we consider a mathematical assumption where we said small angle approximation where sine theta is nearly equal to theta. So we consider a mathematical assumption here. Okay, so here this may also lead to some error when you are releasing the pendulum bob and you are not maintaining that theta value, you are changing the theta value every time, then this may also affect. Then second thing, we said this oscillation is actually, this oscillation should happen on one plane. Okay, on one plane, it should not, like, change planes, right? So that is oscillation one plane. That is also one assumption that was taken, oscillation on one plane, so which may not happen, right? And you have to be very careful to get that thing. And then the third thing, we can say the pendulum should not rotate. A rotational motion will add some other other parameters which may affect the oscillations. There should be no rotational motion around the, of the pendulum around its own axis. So rotational motion should be avoided. Rotational motion should not be there. Rotational motion should not be there. Then you also considered here, when you wrote T equals to 2 pi root over L by G, you considered no air resistance. So no air resistance here. Okay, or drag, no air resistance, that is also one assumption. Now you see, because of this theoretical model, T equals to 2 pi root over L by G already. And also for the string, you said inelastic, okay, inextensible, okay, string, rigid string, so that its length should not change when you attach this heavy metal bob to one end, right? It should not be straight, the length should not be changed, right? So many such parameters you actually considered while doing this particular experiment, just to simplify the the working formula, and to write it as T equals to 2 pi root over L by G. So these parameters will actually give you some error, and these errors will be reflected in your reading as random error. So so mathematical considerations, assumptions, okay, or you said ideal conditions. Okay, the second thing we said, the parametric errors, or you said errors that is accounted because of the variables which are actually not controlled, okay, will lead to random error. Okay, I hope I mean you understood what is the difference between systematic error and random error, and how to avoid random error. So how to minimize random error? Like in systematic error, we said we what we need to do, we need to consider the zero error, or we need to calibrate the equipment before using it, then you can reduce this systematic error. But in random error, what we need to do, you need to take more data points. Okay, so more, when you are taking more data points and averaging it out, then you can minimize the random error. So that's the only thing. Or else you can analyze the random errors from where actually you got, and what is the trend, what is the pattern that the random error actually follows. For that you can do some more statistical analysis to understand the random error. So this is it in this video. Thank you for watching.